opportunity. But if the current government block such outsourcing company, okay? So you will see the last choice of to get a job, find a job in the United States. You probably will be contacted by the staffing company. So like this kind of, some of them criticize such a company as the 21st century slavery, the company. So the high technology will be there. So the very lower. So I think the master degree with the master degree is not the lower skill. It's definitely the higher the skill, the technology, and the area. So it will be. You don't have to be depressed, or you don't have to criticize. It may be the better opportunity for you. But why I explained such a thing? So from the AI. Oh yeah. So this one, to see the future. Nowadays we have the more and more. So the predictive analysis, data analysis, or such AI technique will be used a lot for such a. If we can see the future, or if we can predict the future pattern of the user interface or the user something, so you can have the idea to make the estimate whenever I type. So like for example, it's a spelling check, or you probably use a lot because of there is something weird character. But so how many words you are using? So it's less than 200, really. So typing, if that can be predictable, it's like such a thing. We don't know exactly what I'm going to type, or what you are going to type, but we can predict based on the pattern or the experience, similar things. So we cannot ignore such optimal algorithm. Also, this one will be used for comparison purpose. If you have the better idea, this is an ideal case. No other algorithm will be better than this because it's a see the future. But if you have an idea, the new algorithm you can compare with this one is 99% almost the same as the optimal. So this is optimal algorithm. So this is another example of another one, another reference string. You can use this. You can test, please practice. As I said, I know that you are so smart so that you understand this one in the classroom. That doesn't mean you can get the full credit. So I do not accept you are the appeal. I know, I understand, but because of my mistake, the count is the wrong answer. No other way to compensate for that. Please practice by yourself, and also definitely you need to do during your project. The next one is more practical. It's called least recently used algorithm, LRU algorithm. Anyone who ever heard about the LRU algorithm? Anyone? So. What is a computer, by the way? Computer? Rectangle. Hardware and OS. It's a computer system. Computer is a person who compute. Right? Yeah. Right. So teacher, a person who teach something. Right? Am I wrong? It's correct, but it's not always a person. It can be device, computer. Especially nowadays, we mention whenever we refer the computer, that's not the analog style computer. It's an electronic device. So anyway, compute is the important thing. Compute. Why do we need such a computing device? Fast. Human can do that, but there is a limitation to speed up, to compute something. So we need a fast operation, fast computing. So we always try to achieve the faster or the more job to be processed in the computer. Then, however, there might be limitation rates, computer system, to achieve such a speed to find the data or to access the data or to compute the data. What is the first solution to overcome the limitation of such a speed? Hardware. We need to improve the hardware power, like the higher clock speed. And fast RAM or the fast I/O device, it's also limited. Even though there is Amdahl's law, Moore's law, not Amdahl's law, Moore's law. So every 18 months, the CPU power will be doubled up, even though higher than double, but it's still limited. Another solution of the such to speed up, we always use the cache in between. Okay, so before when we start the operating system, do you remember the triangle? The I/O device. So from the bottom is the tape device, top is a register storage. But you can see a lot of in between, like the L2 cache between CPU register and the memory. Also, memory is called the primary storage and secondary storage, the hard disk drive. Whenever we compile, we program, make the program, it will be stored at the hard disk drive. But when we create the processor, it will be loaded into the memory. Why not? CPU access the instruction directly from the hard disk drive. That will be easier and simple instead of creating the processor. It's a slow device. Okay? To address that one, we can have the faster media always in between, cache. Okay? So cache will be used a lot to speed up in between faster media and slow media. Problem? It's limited. Usually such a cache, the storage is smaller. Like the memory size is smaller than hard disk drive. And L2 cache is smaller than memory. And the register is smaller than the L2 cache, something like that. Then how can we manage? Depending on how to manage such a cache area is decide the performance. Ideal case is if the data in the cache used a lot, we try to keep. Otherwise, throw away. How can we manage? We can have the list of the cache from top to bottom. Top, mostly used. Recently used. Okay? And the other, less used. So that is called LRU algorithm, least recently used algorithm. So LRU algorithm is not only for this one, it's general solution for cache management. Database use also a lot of such a cache, which is called sometimes buffer management. For the buffer management, so they use the LRU algorithm. So LRU algorithm used a lot for such a cache data management, which means instead of see the future, it's not easy. We need to predict. It's not correct. Why don't we see behind? That may possibly, this is the history. So if that one is used recently, we will keep. Otherwise, if not used, then that will be the victim. So that's the idea. So it's different from the first in, first out. First in, first out, we see the arrival time. But LRU algorithm see the reference time. Okay? When is the last accessed? So first, we are going to use the same reference string. 1, 2, 3, 4. We cannot avoid the first, the page 4. Then 1, 2 reference. Then when 5 is the in, we need to decide one of them. According to the first in, first out, 1 will be the victim because 1 is the first in. However, in LRU algorithm, 1 is accessed this time, 2 is accessed this time, 4 is accessed this time, and 3 is accessed this time last time. Okay? So 3 will be least used. Okay? So this one will be selected as a victim page. So 3 will. That's the difference from this one. So in this case, so 1 will be, can you see the 5? So this one will be replaced because 1 is alive this time. This is the first in, first out. But in LRU algorithm, the 3 is here, 4 is here, 1 is referenced here, even though alive here. So don't be confused with the first in, first out. And so on. 1, 2 is the reference. So reference time is here, and the 2 is here, and The 5 is here. 4 is here. 4 is here. Okay? Then, when the 3 is coming, we need to decide which one is the least recently used. All the reference one, that is the 4. We can replace 3. And 4, 5, the next one is 5, and the 5 will be, and so on. So, this is a LRU algorithm. How many pages for? 1, 2, 3, 4, 5, 6, 7, 8. Usually, in general case, the LRU algorithm is better than first in, first out. Okay? Any questions so far? You need to implement the LRU algorithm first in, first out and optimal algorithm in your project. But once you decide the data structure and the class in terms of object-oriented programming, implementing such an algorithm itself is not very difficult. Okay? Then, any problem? No problem? Searching?
Like when more number of frames are there, searching for the
Searching? Backtracking? We need to manage, which means this is arrival time will not be changing, right? It's a fixed, so we don't have to worry about it. However, this when is the last time to use? It's a frequently change, dynamically change along the time. Every time, this is as I mentioned, it's a time. Along the time, we need to keep checking all the value when this one is referenced or not referenced or not. Okay? Even how often, every millisecond, every time, or every reference. So we need to decide. So it's a time-wise problem. Track the time. Actually, that costs the extra space to manage the time for each page frame. So for each page frame, we need to manage. Okay? Actually, computer system, there is no time like our time. Even in our life, the time is, who made the time? Human being. Is there really exist a time? I don't know. I should not be such a skeptical of the general knowledge. I read the article, Flat Earth Society. Have you ever heard about Flat Earth Society? Those who believe our Earth is flat. Have you ever seen the space? The Earth is round or flat? No. How do you believe? There is, you can search. Because the Shaquille O'Neal, the former NBA player, he announced that he believed the Flat Earth Society, but later then he declined. But anyway, so what about the time? Time is the man, human being designed based on the nature. Then the computer does not have such a thing. Instead, it has a clock. Clock is similar as the time, but it's something periodic signal. Okay, we count such a periodic signal. Sometimes we can keep the time that can be understood by the human, similar to such a thing or object. Okay, so we need to consider such along the time to manage which one is updated, which one is not. So that is the key part. That is different from the first in, first out. There are several solutions, like we can use the counter instead of the time, which means for each. If not, if accessed is always 1. So for example here 1, this is 1. However, if not accessed, every event, or it can be every time. The time means is every cycle of the clock cycle, you can increase. Okay? But in this case, for each event, so it can be increased. So in case of 3, it's 1, starting from 1, this one will be increased, 4, and so on. Then, if 1 is a reference, this one will be reset to the 1. Okay? Then, this one will be reset to the 1. Then 5, there is no page frame of 5. We need to decide the victim. When we decide the victim, we can select which one? The page frame having lowest number? No, highest number. Because which means the highest number means oldest, least recently used. So this one will be selected as a victim. Then reset 1 and keep going. In case of the page first, we can select the highest number and then so on. So in your implementation, you need to mention what kind. We will see the more the technology, the more algorithm. So, but this is one of the approaches, naive way, easiest way. Okay, so we can keep the counter of the each page frame. Problem? Where do you keep? Right? And also, it will be the same number of page frame. It will be huge, right? Actually, so for example, 4 byte, if you are using integer, or in case of double, it will be the huge space, and also you need to read and such a thing. So it's an overhead. It's a simple, but you need to. And also another problem is how often update. In this case, event by event, but mostly the practical implementation use the certain clock, the number of clock. Okay, another implementation of the LRU algorithm is using stack. What is a stack? Stack. It's a data structure that you learned in your not elementary school. It's a freshman level, right? In your freshman level, you will learn the stack. Stack is bottom up. Okay, it's a simplify the data structure. There's no the read and remove is combined, and when you insert, it will be just the end of your data structure. It's a pop, push, and when you read, it's a pop. Pop is combining the read and insert. Okay, so that is a step. So step also used in a lot in the computing architecture, including process structure. We have the step, right? What is that? It's a top to bottom. So used for what? Temporary space, right? Temporary variable. Why? So stack used a lot for the temporary space, because it can keep the reverse of the order. Push and pop, you will get the same order of the data. Okay, and very fast. So because of that, the stack can be used a lot. So for the such a, it's a very fast. So computer. So we will get the idea of the stack to manage the such a thing. So we have a stack. Do not think about this is the 2-dimensional array. We have only the 1-dimensional array. The same, actually one more, the entry, then the page frame number, which means a 5. 1, 2, 3, 4, 5, 6. For just in case, let's say the 6. So this is our stack. Okay. Then, whenever it is accessed, pop at the push. Then, if reference, this is a little bit changed, revise the step. This can be if the one is the read, that will be the top of the stack. Okay, it's a revised stack, so it's not original stack. For example, if one is read and always the top of the stack, then the 2 is the reference, then 2 will be, actually here is the top of the stack, like that. Okay, so then, when we decide the victim page, which one will be the victim page? The bottom one. Bottom one will be the automatically the victim page, because it has not been used, the longest one. So this will be the victim and so on. So we can use the stack to manage the history of the reference string. So this is the implementation of the LRU algorithm using the stack. Okay, so you can do the same thing with the reference string. You can do by yourself at home. Okay. So it's a counter and the stack implementation. Then, instead of LRU keeps the which one is the least recently used. Then select the victim. Vice versa, most recently. MIU, most recently used one. Idea is, if the used a lot, there may be lower chance. But assumption is, access probability is uniformly distributed. Okay? If all of them have the higher chance, like think about I'm not a big fan of casino, but last time is 5-6 years ago, but whenever I go to the casino, I play only the roulette because that's simple. So I can decide either red or black, or the odd number or even number, right? So that is a roulette. So then the dealer throws the marble, then there's one of the number. Then, but you can see always the bar and the previous number. So if you see a lot of red, there might be higher chance for black. Is it true? No, do not believe that. But most of people, including me, believe that. Why? Why not? It's an independence event. Okay? The previous one does not affect. So in case of this related, this one, if we can say, because it's the page number, their location may be related, so there might be some dependency. So that makes sense. So at that time, we can consider such a most recently, but most of case LRU. However, in the casino case, I heard that, I'm not sure, so dealer may control the rotation, number of rotation. It makes sense, how many times the dealer toss the marble? 1,000 times a day. So there might be the higher chance. They actually, at least the position, some part of the roulette. Okay, not exactly the one number, but the area of the roulette. So they can control a little bit. I heard that, but do not believe. So such a thing. So do not bet your money for that. But I heard that there might be maybe possibility to control. But they always keep the winning, the percentage is slightly higher than 50% to manage such a thing. Okay, which means you will eventually lose the money. Okay, so then, because the LRU algorithm is expensive, so we try to simplify. So such an LRU algorithm makes sense because it doesn't see the future, instead it sees the past. But problem is it's expensive to manage the history. So next view algorithm is the approximation algorithm. It doesn't keep all the history, instead the period of the history. For example, idea is so simple. For each one, we will keep the reference string. For each the page frame, we will keep the reference. Idea is like that. So which one is 0? Each page associated with the 0. So let's say we have the 3 frame and how many bytes for each? So 1 byte, 8 bit. The associated, the 8 bit associated with each page frame. Then if this one is reference, then set this. Okay? Then next time, if this one is reference, shift left. Okay? This one will be 1, and this one will be 1. It's a shift left, it's still 0. Then if this one is reference, shift. Like this. When you select the victim, which one will be selected according to the LRU algorithm?
Highest number.
Biggest number. Because it's a reference, least recently. Highest number means older. But if this one is referenced again, let's say the next time, reference again. I think there's the opposite way. Let's see. It's been used recently. Oh, yeah. So,
I didn't know
again,
that. I don't know.
1, 2, 3, 4. 8. 8. So 1. So from the left, most significant bit first. Okay? Most significant first, then shift right. So which means next time it will be like that. Then if this one is reference, this will be like this. Then if this one is reference again, then when you select the victim page, which one will be selected the victim? This one is the least recently used one because the one is a reference, which means lowest number. Lowest number will be victim. Why? Because we give the 1 to the most significant bit. Most significant bit means this value is higher than all the sum of the other. Okay? So this one means it's an access. So the recently used one will be most significant bit. In other words, the victim will be selected from the lowest number. Then some of the students complain, any difference from the previous one? Like the counter, what is the difference? First, storage. Okay, 1 byte, but counter at least 4 byte for integer. If you, it will be bigger. Another one is you need to, when you are using counter, you need to plus. Okay, even though plus is provided by the hardware, it takes sometimes some of the instruction need 2 cycles of them. What about bit operation? One of the fastest operation in the instruction, like the shift left, shift right, and most significant bit, or using the most significant bit, you can easily find lowest number, highest number. It's the fastest operation, so it will be faster. But yes.
What happens after 8 cycles?
So that is the limitation. It can keep how many cycles of the period? Only 8. Okay. So which means it's a LRU approximation. It's limited by, if you want to keep a little bit longer, you can keep the 2 byte. Okay? But it's still limited. But that's pretty much enough because it's usually kind of pattern of the accessing the, who will see such a pattern? So this is a LRU approximation. Even 8 byte, I don't want to read the 8 byte. Instead, whether the page is accessed or not, that is called the second chance, which means only manage whether it was accessed or not. 1 bit, even 8 bit or the 16 bit is big, considering number of page frames. So we allocate 1 bit only. Okay, if that one is accessed 1, otherwise 0. So our goal is to find next the first 0, 1. Okay, if all of them are what? 1 round, then the first one will be victim, which means, so I said if this seed is accessed, is a 1, not accessed 0. So it's make the 1 line, okay, like the circle. I'm going to start. My goal is to find the first 0, which has not been used. Okay, so at least 1 round of the searching, I can find the 0. If I cannot find, all of them has been used. Okay, so all of them are 1. Then the first one will be selected as a victim. Second chance. Okay, that is the reason it's a second chance. Second class, at least at most the Worst case is one round and second time it will be selected as a victim. It's not the correct according to the traditional LRU algorithm, but kind of probability. Okay, we can speed up. This is also bit operation, and the how many bit is much less than this one even. So we can save the storage. So that is the second chance. So we can little bit enhance the idea of the second chance. That is to enhance the second chance algorithm. So one is the first bit is a reference. This is the same as this one. If we access the one, otherwise it's zero. Another one is modifying. Whether data is a change. Change means the obvious definitely is a reference. Okay? So if I replace the student by the new one, obviously, or the change something is a reference. Okay? But if I read just the data, that's only reference, not modified. So we will keep both, whether referenced or not, whether modified or not. So 0, 0 means it's never accessed, never modified. First priority of the victim page. If 1, 1 is modified, it's reference, we try to keep. So we do better keep this 0, 1, 1, 0, 1, 1 because it has been accessed at least. Otherwise, if we can find the 0, 0, that will be the first victim. Okay? So this is the enhanced, the second chance algorithm. So LRU algorithm is good. However, regarding to the implementation, it's a little bit overhead. To reduce the overhead, we can consider the stack, but even the stack is takes up the use. It is not traditional stack. So we need to revise. So we can have the approximation, but still this one is need 1 byte for each. So second chance is 1 bit for each page frame, but we can enhance. That is the LRU algorithm. As I said, there is the most frequently used algorithm. Okay. Okay, so I think that pretty much we covered the most of the topic. The rest part, so I quickly summarize. Okay. The key part is whether we can find the free frame one, freeze. So this one is a reserve for specific, the process. So we can keep the pool of the free frames. Okay. Then allocate for the high priority process and some like that. Okay. Also, we can keep the modified page always, like the idea of the second chance algorithm for the modified. Okay, so modified with better keep, right? So with better keep, there's such a modified one. Okay. There are two types of the allocation for the free page frame. One is a global and another one is local, means it's, each process keep their own the territory of the page frame. So which means this one is for process 0, this one is for process 1. Only process 1 can replace in this territory. Process 0 replace this one, that's called the local replacement. However, if you allow the